Okay, we'll go ahead and get started. And I just want to say, first and foremost, hello, everyone. And I am so pleased to introduce today's speaker, Dr. Julie Demuth. Julie is a research scientist at the National Center for Atmospheric Research in the Mesoscale and Microscale Meteorology Lab, working with the Weather Risks and Decisions in Society Research Group. Prior to her work at NCAR, she worked for 3 years in Washington, D.C., as a program officer at the National Academies of Sciences, Engineering, and Medicine for the Board on Atmospheric Sciences and Climate. Julie received her Bachelor of Science in Meteorology from the University of Nebraska-Lincoln, her Master of Science in Atmospheric Science, and her PhD in Public Communication and Technology, both from Colorado State University. With this hybrid background, she conducts research on hazardous weather risk communication, risk perception, and response. For nearly 15 years, Julie has worked to integrate social science and meteorological research with a focus on work directly relevant to practitioner communities. She has published in such journals as Risk Analysis, Bulletin of the American Meteorological Society, and Weather, Climate, and Society. Her work centers on understanding how forecast information, in conjunction with other factors, influence what people think and feel and how they respond. Her current work includes studying how people's previous weather experiences change the way they perceive future weather risks, investigating people's evolving risk perceptions and responses through longitudinal panel surveys collected when a hurricane is threatening, exploring people's perspectives on probabilistic tornado warnings, and identifying National Weather Service forecasters' interpretations of and needs for deterministic and ensemble guidance from convection allowing models, which is quite a mouthful. Earlier this year, Julie was selected as the American Meteorological Society Sigma Xi Distinguished Lecturer for 2020-2021. This is a highly prestigious lectureship wherein the recipient presents a series of lectures in conjunction with various Sigma Xi chapters across North America and abroad. I have had the incredible honor of working with Julie the past 4 years and can say that not only is she a passionate and brilliant scholar, but a lovely human being, mentor, and friend. We are so happy to have her with us today. And with that being said, I'll now turn it over to you, Julie.
Oh my goodness. All right. First of all, I just want to confirm everyone can hear me, right? Okay, wonderful. Thank you, Jamie. That was such a lovely introduction. And I am just so excited and really quite humbled to have the opportunity to give this presentation as part of the IBS series today. So thank you everyone for welcoming me. I was saying earlier when there were just a few folks on the Zoom that I wish we could all be together in person because I just feel like that helps us connect a little bit more, but I'm also really grateful that we have the opportunity to do it in this way. So thank you. And as Jamie mentioned, my background is in both atmospheric science and in communication. So I'm really excited to talk about this work that several colleagues and I are doing on risk communication, perceptions, and responses to hazardous weather. And as I mentioned, let me make sure I get my cursor, there are a lot of colleagues. So the very first thing I really want to do is start by acknowledging everyone. So several research colleagues that have participated in the projects that I'm going to be talking about today, including the amazing Jamie Vickery. I have them listed here in alphabetical order just because that seems like the best way because everybody contributes so much to this. And I'm so appreciative and could not be doing this without those wonderful colleagues. I also really want to thank collaborators at NOAA. So several folks who we work with to help us frame some of our research problems, to understand some of the atmospheric science that's going on. And then of course to think about how our results can be transitioned to operations or have these practical implications. And then most of all, I always really want to thank the people who have participated in our research because they so generously offer their perspectives and their time. And I've often thought about if I were a research subject, how nervous that would make me. And whenever I think about it in that way, I'm just ever more surprised and so appreciative that these folks take their time, forecasters and members of the public alike, which I will be talking about a little bit more. So thank you to all of those people. And also I want to acknowledge NOAA, who has funded many of the grants that I'm going to be talking about here today. So again, my background in atmospheric science and in communication with a focus on risk, I always find that it's really useful to just start with a little bit of a frame so that we can understand some of the concepts that I'm going to be talking about today. Even though they are concepts that we all use all the time, I still think it's good to get us all on the same page. And so the first thing that I want to start by talking about is this term risk, okay, and how I think about risk in terms of weather, but through the lens of the field of risk analysis. And risk is one of these terms that it's everywhere. We talk about all the time. I think especially in this era of COVID, it is something that even the public is very attuned to. But we might use it all the time, even colloquially, without really thinking about what it means. And so these are a couple of definitions that I've put up that I really like. That help us think about how risk is the possibility of an undesirable state of reality or negative effects or adverse effects that can occur as a result of different things, including natural events or human activities. Or much more succinctly, my advisor at CSU, who advised me doing my PhD, he defined risk as the possibility of harm due to an event, right? So when we recognize that this is the definition, or one of many definitions, I'll acknowledge this because risk is defined in many different ways, but a couple of many definitions of risk, we recognize that hazardous weather, in particular stream weather like tornadoes, can certainly cause harm when they occur, and so they are a form of risk. And then just to add to this, two components that are really intrinsic to risk that I think are important that I want to draw your attention to today, because I'm going to be talking about this throughout the talk, are that risk involves the chance of an event occurring, which we sometimes refer to as likelihood, or sometimes also susceptibility, and there's a chance of harm, and that we refer to as severity component of risk. And then the other thing you'll see from the slide is I keep using the word possibility and chance, and this is just simply to draw our attention to the fact that uncertainty is inherent to risk, and it's going to be a piece of what I'm going to be talking about today. So this is risk. Well, then a corollary of this is that we might want to think about what is risk perception. And this is, again, one of those giant constructs that has a lot of different ways that it has been studied and analyzed. But I think it's important to kind of all get on the same page. And I'll be honest, I, for years, was studying research and looking at how people were measuring risk perception and thinking about it, and I couldn't find a definition of it. And it actually drove me insane. And then finally, I stumbled upon these couple that I think are very good, which define risk perception as the judgments that we make about those events or situations or activities that could lead to those negative consequences. And we make those judgments through this process of collecting information, collecting and interpreting signals or any other information about the possibility of that negative event and the impacts it might cause. So as I mentioned, risk perception has been studied really formally, I think at least since the 70s, and there's a lot of ways that we have grown to understand it and think about it. But increasingly, we're really understanding that risk perception is dual mode. It has a cognitive piece where we really think systematically, but also an affective or emotional piece or dimension of risk perception. But even within those two modes, there's a lot of different ways that we can think about and measure risk perception. Today, because I don't have time to talk about all of it, I'm just going to focus on the cognitive side. And even within that, I'm only going to be focusing on two dimensions, which is the perceived chance of an event occurring, what we call people's perceived likelihood, and the perceived chance of harm, their perceived severity. So you can see there's some correspondence here and how I defined risk on the prior slide. Okay, so we talked about risk and risk perception. One more piece I think to help frame us are then, what are risk messages? And again, thinking about what are risk messages in the context of weather. So risk messages are any kind of statements or pictures, signs, any other kind of information that help describe what a risk is or help advocate actions that people can take to learn about the risk or to manage it or help reduce their risk of the event if it occurs. And so if we think about risk messages in this way, then again, applying it to weather, any kind of weather forecast information is functionally then a risk message, whether it's an outlook or watch or warning, information we might get about the chance of rain or high winds or anything. Those are all forms of risk messages. So with that kind of a little bit of focusing on these constructs, then the other thing I want to talk about to frame our talk today is that I'm going to be focusing on the hazard of tornadoes. I got really ambitious when I wrote my abstract, and I said I was going to talk about tornadoes and fire weather and winter weather. I think partly because we were doing some work recently on fire weather, and it's so salient for us all right now. And then I realized I just couldn't do it all, so I wanted to bound it. I'm pulling it in those boundaries a little bit here, and I'm just going to focus on tornadoes. And the reason I think that tornadoes in particular are an interesting type of hazard, weather hazard to focus on, is because they are intrinsically extreme events. So they are statistically very low likelihood, but even if they are low likelihood, they can cause a lot of damage. So they're low likelihood, high severity, or high damage causing potential events. And then tornadoes, when you think about them relative to other types of weather hazards, are very spatially localized. I believe that the largest tornado on record, which if my recollection is accurate, actually occurred in Nebraska, was a little over 2 miles wide. And even though I can't even imagine what it would be like to be in a 2-mile wide tornado, compared to other hazards like hurricanes or winter weather, even some floods, that's actually pretty spatially localized. And on top of that, these events are rapid onset. So they occur very quickly, they don't last very long, and then they end quite quickly. And then meteorologically, tornadoes intrinsically have predictability limitations, both in terms of how much we can predict, but how hard it is to predict them. And that includes aspects of whether tornadoes will even occur, where they will occur if they do, and how intense they're going to be. And so this is a quote from some leading wonderful atmospheric science colleagues who define tornadogenesis or tornado formation as really a Goldilocks problem. That even if the environment is really favorable, we have everything in the right places and in the right amounts, it's still really hard for forecasters to know if a specific storm is going to produce a tornado. And so this is a long way of saying that tornadoes inherently are very uncertain risks. And so any kind of risk messages that come along with them have uncertainty embedded in them, whether it's explicitly conveyed or not. So now I've talked a little bit about these constructs and how I'm going to be focusing on tornadoes, but sort of taking us one step further and helping us with this full frame to talk up for my talk today. Now I want to talk a little bit about how we're thinking about taking all of this and studying what it is that the public does with this kind of information, or when they're faced with tornado risks. And most of the time we're interested in people's responses, right? So what is it that folks are doing to protect themselves when there is a threat of a tornado? Well, those responses theoretically are informed by their risk perceptions. This is one thing that informs their responses, not everything, of course. And then those risk perceptions are informed by the weather forecast risk messages that they get. And obviously, this is a very simplified model. There are many other factors that play in reality. And even within these giant constructs, there's a lot of other dimensions, but let's just work with this for today. And so a lot of the work that my colleagues and I do aim to study this part of the process. But on top of that, our goal is that by understanding how people perceive weather risks and respond to them, even if it's informed by these risk messages, that we can use that information to feed back and help develop more effective risk messages to help them better perceive the risk and make better response decisions. So that's a key piece of what I'm going to be talking about today. So really kind of a main frame. But I do just want to expand this landscape a little bit more and say that even if we know that we have weather forecast messages and we're interested in how it informs risk perceptions and responses, that's not the whole of it. That in reality, those weather forecast messages are originated or written by weather service forecasters, and there are many other forecasters, but we can at least focus here on weather service forecasters. And the information they have about whether there's even going to be a risk and how to communicate that is further informed upstream by the weather research community. So it's important to also be able to look at this part of the landscape. And then going back toward people's risk perceptions and responses, there are many other factors in addition to just those weather risk messages that really shape what people think and what they do. And it's important to recognize that. So if we really want to make strides in improving risk communication or helping reduce the risk that people face, we do have to think about this fuller landscape. And in reality, the landscape is even more complicated than what I'm showing here. So even still, this is very simplified. But this is the frame that I want to work with today. And what I want to do is, there's so many things I would love to be able to talk about. I'm not even going to touch on much of what Jamie introduced me as working on. But I do want to spend a little time talking about some work with National Weather Service forecasters, because I think that they don't often get recognized as key actors in this process. I'm going to spend the bulk of the time talking about some new forecast risk messages that are under development and how people think about and respond to that. And then I'm going to bookend it by just, again, very briefly talking about some of those other factors, namely some barriers that people face, just to kind of give us a big picture, but still letting us dive deeply into one thing. So with that frame, I'm going to dive into starting to talk about some of the research efforts. And again, starting with some work with National Weather Service forecasters. So this is a project that I've had the great fortune to work with two lovely friends and colleagues, Jen Henderson and Jen Spinney. And for this project, we're interested in studying how National Weather Service forecasters and their emergency management partners conceptualize and communicate among themselves, but with the public, about these giant concepts of uncertainty and confidence. And so our goal in this is to understand for them, what are the origins of that uncertainty and confidence? How do they think about it? What does it mean to them? How do they use it among themselves and within an office, but when they're communicating across with their partners here in this forecast and warning system when a tornado threat is evolving and occurring. And the way that we have decided to do this, that we've approached this, is through this multi-sided ethnographic observation, although not a deep ethnography. We really were only in the field for a few days, where Jen and I went to respective offices. I went to the National Weather Service National Forecast Center, where their job is solely to issue forecasts for severe weather. Jen Henderson went to a local forecast office, and Jen Spinney went to an emergency management office. And we were watching them over the course of several days when there was a tornado threat, as they were thinking about and talking and observing and assessing and communicating about this tornado threat. So we did those observations, but then also coupled that with interviews. And as you can imagine, there's quite a bit of results and information here. But the one thing that I wanted to convey from this is really how inherent and fundamental uncertainty is for these National Center forecasters. So that's the office that I went to. And I just wanted to put a couple of quotes here to illustrate how they talk about this, what they grapple with. And I love this quote from this one forecaster who says that the language of nature is uncertainty. And you can see here that I have a couple of other quotes. There's going to be quite a bit of qualitative data in here today. I have a couple of quotes from forecasters where they're really talking about the uncertainty that they grapple with. This forecaster number one is basically saying that they've learned through association that they need certain parameters to be in place, and that we've learned when those tornadoes occur, those things are usually happening, but they're not that causative piece. There are days when they look and all of those parameters and pieces are in place, and they know that they're in place, and storms start to develop, but nothing really wants to fire. The storms are kind of weakly rotating, but they don't really look really good. They don't want to produce tornadoes. And they're saying, well, but we thought the environment looked more potent than that, more poised to cause tornadoes than that. And then because this was part of a joint conversation, another forecaster says, and then vice versa. Sometimes you have those ingredients in place. And he talks about shear. These are kind of technical terms, shear or CAPE, which is a measure of instability or lift in the atmosphere. That those things are kind of mediocre, but then all of a sudden these storms mean business, and they didn't see that coming. So they need to jump on it in a different way. So these are the folks, again, these are the best of the best. This is all they do is forecast this year round for the entire US. And they're still saying that there is so much uncertainty in the process, even right up until those tornadic storms actually start producing tornadoes. There's so much that they don't know. And this is even after decades of atmospheric science research to try to reduce those uncertainties as much as possible. So because there's still uncertainty, this really sets us up and points me to the second study, which I'm going to spend the most time talking about, which is new efforts toward more explicitly conveying that uncertainty, even in a warning environment, and seeing how people might respond to that. So the future of tornado warnings is exactly that, to more explicitly convey this uncertainty, specifically as probabilistic information. And for those of you who aren't familiar, tornado warnings currently are what we call deterministic or binary. So you're either inside or outside of a tornado warning polygon. And I'll just a reminder that by tornado warnings, I mean that tornadoes are either imminent or occurring. And that binary polygon then therefore implies that there's an equal likelihood of a threat of a tornado occurring anywhere inside that polygon. So it's 100% inside, and then it drops off to essentially ostensibly zero outside of that polygon. But of course, in reality, we know that the actual chance of a tornado occurring is probably a lot more nuanced than that. And as the atmospheric science community is better understanding tornadoes and doing better numerical weather prediction modeling and incorporating those observations, they're able to start explicitly characterizing those probabilities in a more nuanced way inside that tornado polygon. And this is really the future of where the Weather Service wants to go. They've been working on it for over a decade, and they're poised to be able to make this operational. I don't really know what the timeline is, but let's just say in like the next 5 or 10 years. But while this is the research that's going on in the atmospheric science community, our goal is really to understand how do members of the public interpret and potentially make use of this kind of probabilistic information before we go from this major shift of deterministic warnings to probabilistic warnings. And so, like I said, that's what I want to focus on for the most part here today. This project that several colleagues and I have, several colleagues at NCAR and the University of Florida, University of Washington have, where we're trying to understand how is it that people would interpret and use this probabilistic information before we make it operational. So there is quite a bit of related research along these lines, including research that explicitly looks at how we would communicate forecast uncertainty in the weather community. And from some of this past work, we've seen that if you give people a deterministic forecast, like a binary yes or no, that people generally are inferring uncertainty into it, even if you're not explicitly telling them that. There's also been research to suggest that if you do explicitly convey uncertainty, that it can actually enhance people's decisions, but that's only if you can design the information in a way that really corresponds to the decision that they have to make. But what's really important about these couple of studies that I'm referencing here is that this has only been done in the context of weather that is not extreme, like tornadoes. So just looking at probability of precipitation or uncertainty about temperatures or about wind. And that's a very different type of threat that people face and decisions that they make in those kinds of contexts versus if they have to worry about a tornado that might be affecting them. So we really wanted to study this in this particular extreme hazard domain. And then another key piece, which will tie to something I'll talk about, is there is some research more in the judgment decision-making field that if you convey probabilistic information about the chance of something occurring, there can be what is called a severity bias, where the probability of an event influences what people think about how much damage could be caused by that event. And the reason that's important is because in a tornado context, if you have a low probability of the event occurring and people think that it means that the damage won't be that bad, when in reality it is, then that's a problem. And so we wanted to be able to assess this particular hypothesis. Does communicating the chance of a tornado make people think that it's saying something about how much damage could be caused? And so when we go a little bit more specifically into work that's been done on probabilistic tornado warnings, because as I mentioned, the weather community has been thinking about moving in this direction for a while, there has been some research that's been conducted to look at how people might interpret this information. And so far, this has all been done with experimental design, which is great because we've been able to test different conditions and see causally what those effects of those conditions will be. But our goal with this particular project was to augment that experimental work with interviews with people who have a lot of experience with tornadoes so that we can understand how they might perceive and use this information given the very real world context of their lives, given their past experiences, their sheltering options, their beliefs about tornadoes. So that's what I should also mention that this actually is part of a multi-method project where we started with experiments. We did do that as well. And then we're following that with these interviews. So as you'll see, some of our interview methods look a little bit like experiments because we were trying to do some cross comparison across these two. So this is how we designed our interview protocol. We started by designing a few different warning conditions, including a deterministic condition. That's that binary yes or no. You're either in the warning or out. You can see that on the left-hand side here. We also created a red color probabilistic condition, and it's a little hard to see, but those colors represent probabilities. The lightest pink is 10%, then it goes to 30, 50, 70, and the darkest color is a 90% chance of a tornado occurring. So that's the red color probabilistic condition. And then we also created a numeric probabilistic condition, which is what you see there on the right. We presented this, though, as text information versus in a spatial frame. And our reasoning for this was because we were interested in seeing how people would interpret this if, say, this information was conveyed to somebody via their cell phone, where they didn't have an opportunity to look at a map. So these are the conditions that we developed. And we put people in a hypothetical scenario. We gave them a lot of information, told them that they were at home, that it was a weekend, that it was afternoon, that they were aware that there was a threat of tornadoes. And then we told them that they received a tornado warning on their phone and that the warning told them that there was a severe thunderstorm capable of producing a tornado, where the storm was located, where it was moving, and how long it was in effect for. And this is because this is the kind of information that you get if you get a tornado warning nowadays, even if it's not with the probabilistic information. What's key here is we did not tell them anything about the severity because in practice, in reality right now, we don't actually know how intense a tornado is for the most part until afterward, until we've done a damage survey. So we didn't convey that information because it's not going to be actually available even in the future. So this is how we started developing the interview protocol. And then in addition to those few conditions, we place people at different locations. And so you can see that we place people at a condition outside the polygon, at a 10%, 30%, and a 90% location. Of course, that was explicitly conveyed in the probabilistic conditions. In the deterministic conditions, we still place them at those locations, but of course the probabilities weren't explicitly conveyed. And so we put them at these different locations because we were interested in seeing how they would think about the chance at these different places, but then also the chance of a tornado occurring, the severity, but then also what they would do. And so these are really the questions that we asked with that particular design. So our main dependent variables, we actually had quite a few of them, but the ones that I want to talk about today are really structured around people's risk perceptions and responses. And again, those two dimensions of cognitive risk perception. So we were interested in people's perceived likelihood and severity. And we asked the question in the interview in a couple of ways. First, in an open-ended frame, where we asked them what they could say, if anything, about the likelihood a tornado would hit their location, or for severity, how much damage could be caused. And then if they could say something, we asked them to mark a scale. And this was in person, this was pre-pandemic, so we were able to do this in person. And they marked the scale on a piece of paper. And the reason we did this was because this gave us a chance to look more in a more direct way at some of the results in conjunction with the experimental results. But it also gave us a sense of sort of how their quantitative responses matched what they qualitatively would describe to us. So we have this quantitative and qualitative data for the severity and likelihood, but then just a qualitative response about what they would do if they were in their home to get a sense of what those intended responses might be. As I mentioned, we did these pre-pandemic, so we did these interviews about 18 months ago in Tuscaloosa, Alabama. And this is, again, because we were interested in a tornado experience sample. So we did interviews with 36 people. Rebecca Morris, Kevin Ash, and I conducted the interviews. And you can see the characteristics of our sample there. A key thing to note is that nobody in our sample was colorblind, which is important for that red color condition. And then the other key thing I want to draw your attention to is, again, this was a very tornado experienced sample, according to their self-reports. Everybody reported that they've had some to a lot of experience taking action to protect themselves from a tornado. And then 2/3 said that they have some to a lot of experience with tornadoes firsthand, whatever that means to them. So again, very experienced, which is exactly what we wanted, what we were seeking with this particular research project. So now I'm going to dive into the results, and I'm going to start with the results about their perceived likelihood. So again, we asked an open-ended frame, and then we had them mark a scale. And the way that we took this marked scale and converted it to quantitative data is that we measured how far from the left side of that scale people marked, and then we converted that proportion on a scale from 0 to 100. And so you can see, I'm going to start by showing the quantitative results. You can see that these are that's what's along the y-axis of this plot that I've got here. So these are where people marked on that scale is that perceived probability on the y-axis. The x-axis actually represents those different underlying probability locations that we placed people at. And just a reminder, of course, in those red color and numeric probabilistic conditions that was explicitly conveyed. In the deterministic, it was not, but it was still, we're still imagining that that is the underlying probability. And then one final thing to orient you to this plot. So what I'm plotting are people's mean perceived likelihoods. The black line is the deterministic condition, red line of course is red color, and then the green line is the numeric condition. And for a reference, we've also drawn a gray line to sort of show exactly where 10%, 30%, 90 would be so that you can more easily compare the mean perceived likelihood responses. So there's a lot that you can glean just from this plot alone. And a couple of those things that I want to draw your attention to. First is how people responded to that numeric probabilistic condition. On average, their perceived likelihood is closest to that underlying probability. So what they're reporting is very close to what we told them the probability was. In the red color probabilistic condition, though, people are systematically overestimating that tornado likelihood, even though we tell them what the probability is. So they're doing this more at that 10% and 30% location, so that's more on the perimeter of the polygon, less at that 90% condition, although I think that's somewhat potentially have a ceiling effect here. But they're still systematically overestimating beyond what we're telling them. And then the final thing is that in that deterministic condition, again, where we're not giving them probabilities explicitly, people are inferring a distribution regardless. And the distribution that they infer is that there's a higher chance of a tornado occurring near the centroid of the polygon and lower as you go toward the edges. So we are seeing some similarities from past work where people are inferring uncertainty, even in this kind of extreme weather situation. But even though people are inferring that uncertainty, the range is relatively flat compared to the probabilistic conditions. So these are those quantitative results. Now I want to show you a little bit more about how people are talking about this, starting first with that deterministic condition. And on all of these slides, there's quite a bit of information, but just to orient you, on the left-hand side in that dark blue, this is our characterization of like the key theme that is coming out of these quotes. And then of course I have the quotes in the blue boxes. So two of the key ways that people are reasoning about the likelihood in the deterministic condition is by first bringing to bear their knowledge about where the storm paths usually are, or how storms usually move and how they evolve. And you can see that from these couple of quotes here. Person 18 says tornadoes pretty much follow the same path every time. person number 27 is thinking about the likelihood farther away in the downstream part of the polygon. And she's saying, well, the tornado's still pretty far away. It could potentially change paths. And so that's shaping what she thinks the likelihood is. People are also talking about what is functionally the limited predictability of tornadoes. They're not using those words, but that's really what they're conveying. As person number 22 is saying, well, the tornado could go anywhere. It could make a circle. You could never predict it. We also see that some people are reasoning about the likelihood in a way that matches those quantitative results I showed. So person number 15 is functionally really talking about how there's a higher likelihood in the center of the polygon and lower toward the edges, which is what we saw quantitatively. But then you have other people like person 20 who is actually bringing in these other factors. In this case, the trust that they have and the expertise of the forecasters who are issuing these products. So you have this person who says for them to even classify the area I'm in, a polygon tornado warning, the probability is high enough. Professionals have said there's a good chance of it happening. That's enough for me to say that it's certain. So this is above and beyond any other information that is being conveyed. So these are ways that people reason about it in the deterministic case. We see some similarities in that red color probabilistic case. So again, you have people who are bringing to bear their beliefs about the storm path or evolution, or about the limited predictability of tornadoes. But now they're also layering in that additional probabilistic information that we're providing to them. So you can see person number 1 who says the tornadoes tend to follow the same path, they don't really shift. And she's looking at that dark red and says, if that dark red follows the lighter color reds and pinks, it's gonna be right on top of where I'm at. So she knows the storm's gonna evolve. And so she's thinking about the likelihood accordingly. Or you have person number 8 who's talking about that limited predictability and says, even though it says 30%, there's always a chance. I don't think anyone ever really knows because we've seen tornadoes take turns. So very much drawing on their experiences there as well. One thing we saw that was unique to this condition is that because we have, of course, we're conveying this with color, that for some people, the color did connote where the storm was located. As person number 3 says, I feel like the likelihood is higher now that I know where the tornado is at, and really focusing on that dark red as a way of conveying to them where the tornado is at. And then finally, people reason about the numeric condition in a way that really matches those quantitative results, which is just that they say it's clear cut. It's easy to understand, very straightforward. You don't have to think about it. I'm not really going to analyze it. It means what it says. So in a much more straightforward way. So one final thing I wanted to share about how people are thinking about the likelihood pertains specifically to that 0% location. So I didn't talk about this when I showed the plot earlier. But again, we did ask people what they thought the probability was outside of a polygon. And we did this in the deterministic and the red color condition. And on average, you see that people think the chance of a tornado occurring there is about 10 to 20%. And again, you see that people are reasoning about this because of their beliefs about the limited predictability of a tornado. You have somebody who says, you never know when the winds are going to change. The tornado makes a hard right and comes right at you. But people are also bringing to bear their knowledge about tornado forecasts or tornado threats in general. And person number 2 here is functionally saying that even if you're not in that warning, you're probably in a tornado watch, because watches are usually in effect when warnings are issued. So because of that, I wouldn't say that just because you're not in the warning, that you couldn't be affected by a tornado. So it's still not a zero chance that you'll be affected. So those are the responses about the likelihood. Now I want to move into people's responses about the perceived severity. Again, our interest here was we wanted to see if people were conflating when we conveyed something about the chance of a tornado, that would say something about the damage. So we asked them again in an open-ended frame first, but then also had them mark a scale if they felt like they could say something. And first and foremost, because people did have the option to tell us that this didn't give them any information about damage, we saw that a quarter of our sample, 9 people, consistently said that they could not provide some information about severity because that's not the information they were given. And they conveyed this in really 2 different ways. We had some folks who would say this more indirectly by saying that tornadoes can vary in the amount of damage that they can cause. As person number 33 says, you know, they can knock over 2 trees or maybe destroy a whole town. It's really hard to know. And then you had some people who were much more explicitly said that the information we provided about the chance of a tornado doesn't tell them anything about the damage that could be caused. So these are 9 people who wouldn't provide a severity response across all conditions, all locations. But then we wanted to see what the people were thinking about the folks who could provide a response. And first, I want to show those quantitative results. And this plot is a little confusing, so just bear with me while I explain it. The way that we wanted to characterize the quantitative results here were that we first looked at the difference between how people responded to the perceived likelihood and perceived severity. We took the absolute difference because we didn't care what direction it was in, and then we did a mean of that across all locations. And what you need to know in order to interpret this is that if there's a bigger difference between how they responded to severity and likelihood, that means that there's less confusion. It means they're not responding to those two things similarly. If there's a smaller difference, they're more likely to respond similarly. That means that there's more confusion. And so just on average, what you can see here is that there's more conflation or more confusion about the probabilistic information saying something about severity in that red color condition and in that numeric probabilistic condition. So in both of the probabilistic conditions, and there's least confusion going on in that deterministic condition, according to the quantitative results. But what's important here is to dive into qualitatively how people are talking about this. And so what we are seeing when we look at how people are describing this is that in reality, there are some people who are truly conflating this. As you can see from this quote where this person says, well, if you only tell me there's a 10% chance, I feel like even the rain and wind is not going to be as strong. So that is happening in some cases. But what we really see is that even though people are responding to that conflation, or responding to that severity, that they're really thinking about what could be happening in very complex and sophisticated ways. So when they're considering the damage that could be caused, they're thinking about the natural and built environment, or they're drawing on their perceptions about how prepared people might be, or how prepared the city of Tuscaloosa might be, as indicated by some of these quotes. So just to highlight quote person number 10 here, who's really looking at the area that's under a warning and saying, well, there's all these cities in between. If those cities are affected, there's going to be damage, but if it hits in between, a lot less. Or you have somebody who's saying, well, I don't think there's going to be a lot of damage because Tuscaloosa as a city as a whole is pretty prepared. So it's not just a straight conflation that's going on, but these ways that people are reasoning about it, again, and that are much more sophisticated than just simply confusing the two. And then finally, I wanted to show a couple of results about how people indicate that they would respond, what they would do if they were in their home, given these different kinds of warning information. And I'm focusing only on the 10% location because we were really interested in what people would do if they were on the perimeter of the polygon or at these lower probability locations. And some of the responses that emerged are that people would seek shelter. As this person number 20 says, I believe the professionals, again, you see that trust coming up, I would seek shelter immediately and just say there's a probability for it. So we had some people who would straight away say that they would seek shelter. And they did this interestingly they responded this way only with that deterministic condition. But we saw with some of those other conditions that people weren't necessarily seeking shelter, but they weren't ignoring the threat either. So they talked about ways that they would be vigilant, that they would pay attention, or that they would seek information, as you can see from these quotes from person 17 and person number 33. I love 33 who says, I would be vigilant. I would still probably seek more information and keep a close eye. Anything more than 0% chance is something to be concerned about. You also have people who say that they're going to think about people who might be in the other high probability areas and notify them. So information share about the threat with their loved ones. So even though folks aren't seeking shelter, they're not, again, ignoring the threat in any way, shape, or form. We actually only saw 2 people who said that they would truly do nothing. As you can see from one quote here, it wouldn't make me want to do anything because it's almost close to 0. And interestingly, this only happened in those numeric, that textual condition. So that's how people would respond to these different probabilistic, deterministic and probabilistic warnings. So just to summarize, what we're really seeing from this research is that there's no single perfect warning. So each one of these has their advantages and disadvantages, or trade-offs as they've been characterized by other people. We do tend to see that there aren't any really obvious disadvantages to that deterministic condition. Even though we see that explicitly conveying probabilities helps people better know the chance of a tornado, that's the only advantage that you're really getting different from the deterministic condition. We definitely see that there is some conflation of severity, not a lot though, some conflation in those probabilistic conditions. And then we think about how people are going to respond. We see at those low probability locations that people do shelter in that deterministic condition, which is really good. But even the folks who aren't sheltering aren't using, they're not completely ignoring the information. And you only have a couple of folks who are really doing that, and that tends to be more in that numeric condition. And then another key takeaway here that I think probably isn't a surprise to many of us here, maybe more surprising to some of the meteorologists, is that people are bringing to bear their knowledge and their beliefs when they're interpreting this information. Even when we're explicitly giving them probabilities, they aren't necessarily interpreting it just at its face value, and that color further shapes those perceptions. So obviously the goal of this kind of information is to help engender people to be able to take protective action, to really protect themselves when the tornadoes are threatening. But what we also know is that there are things beyond just people being able to get this kind of information and interpret it and make sense out of it. And that's really how I want to wrap this up, by just touching on another project that Jamie has actually been involved in, as well as several other folks at NCAR and Kevin Ash from the University of Florida, where we've been trying to look at how people are perceiving risk and how their responses, how they're responding in a dynamic frame as a tornado threat is evolving, but also really importantly, how vulnerabilities that they are faced with interact with this information and their ability to do something. And so the way that we've done this is through what's functionally a quick response set of interviews. So after two deadly EF3 tornadoes occurred in southern Georgia, Heather Lazarus, Jen Henderson, and I went into the field and went to the areas where the fatalities occurred and spoke with neighbors and family members, and retrospectively did interviews to understand what information people had, what they were thinking, and what they did. And then Jen also did interviews with the National Weather Service forecasters who serve that area. And much like the forecaster work that I showed at the beginning, there's quite a number of results that are coming out of this. But the key one that I really want to draw your attention to here is that for many people in the Southeast, there really is no safe place for them to go. And you can see that reflected by a couple of quotes from members of the public that we interviewed, where they explicitly said, there's no safe place. This tornado took out big homes. There's nowhere for us to go. Or this very powerful quote from these other folks whom I'm calling Sally and Jim, who were saying, we were sitting in the closet. We know we ought to do something because we know the tornado's coming, but we have no place to go. There's no shelters or anywhere like that or anything like that around here. So while that tornado was occurring and killed people just, a stone's throw from where they live, we were just right here in that dinky little hallway holding onto each other really tightly. Such a powerful, and these people were so lovely. Just can't imagine them having gone through this experience. But they do explicitly say there's nowhere for them to go. And even the forecasters who Jen interviewed acknowledged this and said, not everybody's going to have shelter or good underground shelter. Maybe they can go to a ditch, maybe they can get in a culvert, but there's really not a whole lot that these folks can do. And this result has been verified in different ways from other researchers who are doing work in this area, of people who explicitly say there's no safe place, or some recent work by Stephen Strader, focused more in Alabama, but I think is relevant throughout the Southeast, has found through GIS analysis that the distance to a community designated shelter is nearly double that for people who live in mobile or manufactured homes as compared to people who live in permanent homes. And that distance translates to them taking an extra 5 to 10 minutes to get there. And given that tornado warnings are typically in effect for no more than 15 to 30 minutes, or typically have a lead time on average of 13 to 16 minutes, that 5 to 10 minutes longer that it takes for them to get there really translates practically to a lot. So with all of this, I want to wrap up by putting that big landscape back up here and recognizing that when it comes to trying to improve risk communication in its broad form of what I intend it to mean, or really help develop risk reduction strategies that help folks, we have to recognize that there's a multiplicity of challenges here, and that recognizing that helps us think about the multiple solutions that are truly needed to improve everything that is needed. And I'm still just barely touching on just 3 things here, but just 3 needs that I think are emerging. First, going back to that work with the forecasters, we definitely need additional research in the weather community to help them better discern when tornadoes are going to occur with more accuracy and ideally with longer lead time, so that those forecasters can better assess the threat and create information, better forecast risk messages for the public to then use and respond to. So that's a key need. That second study, I think, is helping us understand that there is still more social science research that's needed to better understand pros and cons of probabilistic warnings. Do we even want probabilistic warnings, or are deterministic warnings still the way to go? And I think that we need to do this across different populations, definitely across different types of tornado threats, because not all tornadoes are created equal. There are nocturnal versus daytime, really classically supercell type of threats versus more linear threats. So understanding how people would interpret this across that suite of different tornado threats is essential. And then also looking at it in conjunction with other risk messages that we know that they're getting in real time, so that we can truly understand how people would use and understand and use this kind of information. And then finally, that work, I think, that I showed at the end about there being no safe place is really underscoring this need for more community-centered approaches to really identify and develop safe sheltering options for everybody, so that they do have places that they can go, and potentially in conjunction with that, provide more accurate, longer lead time information, forecast information, so that people have time to get to safe places if it's not somewhere that they can get to in the course of a few minutes. So with that, I see that I'm hitting about the 42-minute mark, a little longer than I had intended to go, but I do want to just wrap up and put the many references that this work draws on here and offer my email in case there's any questions. But just thank you all so much for listening, and I'm happy to take any questions that you have.
Julie, thank you so much for that fabulous presentation. It was just, your work is fascinating and so incredibly important. And a virtual round of applause. It's hard, as Lori said last week, it's so hard to be in this virtual setting and not be able to hear the claps, but I know that they're happening. So as Julie mentioned, if you would like to either raise your hand on the little, like the digital hand raise, I can look and see if anyone has questions, or you can type in questions in the box. And depending on your preference, Julie, if you'd also like for people to just unmute themselves and ask questions, that's perfectly fine too.
That's perfectly fine. That's great.
Getting a lot of great feedback in the chat box. And looks like Lori has a question. We have a few questions here. I saw Lori and Steph Mulbourne pop up first.
Okay, thank you, Jamie, for being our moderator. And Julie, thank you so much for the presentation. I have so many questions, but I wondered, one I'd love to hear you talk a little more about is language in these warnings, as the Weather Service is developing these warnings and thinking about all of the complex ways to convey not just the risk information, but also the actions that are to be taken in response to the risk information. And can you just talk to us about the various mediums through which they're thinking about rolling this out, about different beyond English languages they're talking about using in this process and how this may complicate the process, and then just more broadly how they're thinking about diversity and how your research as a social scientist is helping to bring in context and diversity into this realm. So thank you.
Yes, thank you for that question, Lori. I think I got all the pieces of what you asked. So I think to speak to the last part of what you said just first about how they're thinking about diversity is, I think that this is fledgling, that they are starting to think about diversity in these more nuanced ways than they used to. And this is, I think, born out of this wonderful collective of social science researchers who are starting to contribute to this space and really have been over, say, the last 5 to 10 years. And so there is more work now that is looking, I don't think that there's been a lot that's been looking at non-English speaking. That's still not happening very much, but there is work that is looking at blind and deaf and hard of hearing communities so that we can understand what information they're getting, what are the main sources and channels of that information, what are barriers of them interpreting or understanding the threat and being able to do something. In fact, that Kathy Sherman Morris article that I think I've referenced here, yes, so it's the tornado warning awareness information and barriers for individuals who are blind. They were also one of those key groups that this issue of no safe place emerged. But especially when you start thinking about this information that is really visually rich, how that gets translated, especially if we have to be communicating probabilistic information to people who are sight impaired, and that's particularly challenging. So that work is happening, but it's still very slow. I would say it's quite fledgling. I think to go to your first question about the language and how actions to be taken are conveyed. So all National Weather Service warnings have, trying to remember the exact what it's called, like preparedness and precautionary actions that they have recommended at the end of every one of those warnings. There is sort of a set of what that language is, kind of a canned set of it. Many times, depending on the medium or how that warning gets picked up and parsed, some of that information can get truncated out. So I think, though, we have to really rely on not just like the specific warning information that's coming from the originators from the National Weather Service, but also thinking about how broadcasters are absolutely key in helping people understand what they can be doing. And not just when there's a warning, but hopefully in the days leading up to it. So we are seeing through quite a bit of work how people are getting this kind of information as the tornado threat evolves over several days. And if they're paying attention to their broadcasters and what their broadcasters are telling them about get your safe place ready, or know where you're going to go, or pay attention during these hours because this is when the threat is going to be worse. I think there is still this issue, though, of not everybody has a place that they know that they can go. When Heather and I were in the field for that event that I was just showing results for, I think that there was an idea that people were hoping that they could go to a church, but they weren't sure. This one person really explicitly told us, she's like, I don't know if I can go to that church if I'm not a member of that church. And so like there's these questions that people partially think through, but I think they don't fully think through until they're in the moment and they have to really be making these decisions. Or people who wonder if the Walmart is safe, or if a certain other building is safe. And so a big piece of what we're trying to do more in the Vortex Southeast community is really couple some wind engineering research to know where is safe, or where are the suite or the spectrum of safe places that people can go, even if it's not the most ideal underground shelter, so that that information can get established, but then communicated to people when these threats are occurring. But another thing you're touching on, and this is so key in as being known in the risk community, is that you can't just tell people about the threat, but you have to give them this efficacy component, tell them what they can do about it to protect themselves, because otherwise they don't necessarily know. And then I guess I touched briefly on your question about the medium. I do think that new technologies are offering incredible opportunities for this information to go out from many different sources, to have redundancy in this kind of information. But there are the challenges of if they are limited in terms of how much information can be conveyed. I think that sort of efficacy component is often one of the first pieces that gets left off, because we start by just communicating what is the threat, not what you can do about it. But I think that there's still such a need for more systematic work, across events, across populations, so that we can fully understand where those challenges really lie.
And next we have Steph Mulbourne has her hand raised, and we have a question in the comment box after that.
Julie, thank you so much for a great talk. You really, in your answer, sort of hit on what I was attempting to get at. Growing up as a kid in tornado country, with, like you were saying, with the couple sort of huddling in the hallway, there was nowhere to go. And so for me, those tornado watch and warning, those communications were just very traumatizing as a child, right? Because as a child, you don't really have the efficacy. And so I think your focus on the efficacy piece is so important. I'm wondering, do you, in studying risk communication, do people think through the role of children and the way that messaging can affect them, and the way that efficacy sort of isn't there in the same way? How do you think about those things?
Oh, that's an interesting question. So I'm not doing any research along those lines. I'm going to have like 3 answers to your question. I haven't seen anybody who has really thought about children from an efficacy standpoint in any context, to be honest with you, much less a tornado context. So that's a really interesting idea. There is some work that's being done in the risk community. There was this fantastic keynote a couple of years ago about a woman whose daughter got very ill, and she was probably 5. And I guess her daughter asked her a question. It was such a powerful story, which again is one of those things about risk perception, how powerful stories are. Her daughter asked her if she was going to die. And apparently the mom said, probably not. And her daughter responded by saying, what does probably mean? And so the good news is her daughter is fine, but this spurred this risk researcher to start thinking about how kids can understand probabilities, or how they, and even if they don't necessarily do it in a formal probability analysis frame, that they can understand these ideas very qualitatively. And so she's been doing some work along those lines, which again isn't really quite getting at the efficacy in the way that you're thinking about it, but is really giving a lot more credence to how much kids can understand about risk. And then one other piece that kind of touches on the children thing, there has been some work, and I am not well situated in the latest on this, the latest research, but that shows that it's often kids who learn about protective behaviors in school about tornadoes are the ones that then can communicate that to their family members when they're actually faced with a risk. And so that has definitely been something that has been discussed specifically in the tornado context. So a lot of ways that efficacy of children does play a role, but
Nice.
I think there's a lot more to be done there too.
That's great. Thanks.
Yeah. Thank you for that question. That's a great question.
We have a question from Jessica in the chat, and she thanks you for this talk, or they thank you for this talk. And did you use any examples with tornado warnings tailored with particularly dangerous situation, PDS warnings, where deadly tornado is on the ground and included within the warning?
So first of all, I love that somebody knows what a PDS, tornado warning, is. This makes me so happy. Or a PDS watch even. No, we have not done that. So that is a great question, and that gets at what I had listed here about the need to do that kind of probabilistic tornado warning research in a lot of other contexts. We do actually have a new grant with that same group of people who we've been doing the probabilistic tornado warning research with, that just started last month, where we want to start to look at this in an evolving frame. So obviously everything we did here was just static, hypothetical. I mean, it's still going to be hypothetical in the future, but where we can look at, I don't think we would necessarily frame it as a PDS warning, but a warning that propagates and evolves. So now you have changing probabilities. We could maybe consider doing an experimental condition that would have sort of a PDS frame with it. I hadn't really thought about it. It's a good idea. But where we can, start to basically emulate a storm that is propagating potentially a long track tornado. And then in conjunction with that, we're also going to have probabilities at longer lead times, what they're starting to call the warn on forecast lead time, where we can, something to bridge the watch and warning periods. And there's a lot of interesting questions around that, because those probabilities are going to be a lot lower at longer lead times, and how you verify them, or what those probabilities refer to, what we call the reference class, is going to be different for those longer lead times versus an explicit warning. So we're interested to see how people are going to be responding to that. But again, I think being able to do this kind of work before it gets operationalized, considering all these factors that are going to be realized in the real world, whether you have a PDS watch, whether you have a PDS warning, whether you have a long track tornado, or especially in the Southeast, they have a lot of marginal situations. And like I was saying, what they call QLCS, quasi-linear convective systems, which are like junkier systems that are a lot harder to predict, for which the probabilities might really look different. I think it's essential before we can start to think about truly operationalizing this, to understand what those results are like, and can we triangulate across all of these situations is key.
We do have about a minute left. If anyone has any remaining questions or comments for Julie, I'd be happy to read them from the box, or you can go ahead and unmute yourself.
And again, I'll put my email up there in case anybody has any follow-up thoughts after this, or just that you want to share one-on-one. I'm always eager to hear what people are thinking. These are great questions, and I very much appreciate everybody's time and attention today too. So thank you.
Thank you so much, Julie, for your time. Of course, I have a number of questions that I'll talk to you about, just picking your brain on a few things here and there, but really, really appreciate your time today and sharing your experience, your expertise. This has been truly wonderful, so thank you very much.
All right. Thank you so much, everyone.
Thank you. Thanks, Julie.
Okay, thank you.
Very interesting.